Thank you for joining me for this video. I am Mr. Ish. I hope everyone's doing well. It's an excellent derivative application here with a very good shortcut. To determine the slope of a tangent line at any point on a unit circle, there's a very quick shortcut for doing it using parametric equations, and I'll show you what it is. If you have an example, let's say x squared plus y squared equals 4, and I want to find the slope of a tangent line for theta at 210 degrees. What does this mean? Think about it, just graph it out before we get into the shortcut. If you are looking at this, at 210 degrees it would be somewhere right over here. What's the slope of the tangent line over here? What is it? And we are looking here at 210 degrees. What would that slope be? Well, it's an excellent shortcut. For any point on your unit circle, you can define that point by means of parametric equations. X here is always equal to r cosine theta and y is equal to r sine theta. That's what it is. Think about any unit circle as x squared plus y squared is equal to r squared. When you do the derivative of this, you have 2x plus 2y, y prime is equal to 0. You solve for that y prime and you get minus x over y. This is what you have. Now take these items and substitute them over here. What will you have? You'll have minus. Your x value will be r cosine theta divided by your y value r sine theta. What you will realize, the radius cancels out. The only thing you're looking at it minus cosine theta divided by sine theta, and then you have minus cotan theta. Minus cotan theta represents the slope of a tangent line for any point on a unit circle. The radius, because it cancelled out, became irrelevant. You're only looking at the angle. If I'm looking at this question, what is the slope of a tangent line at 210 degrees on this unit circle? Again, the radius is irrelevant. The only thing you need is this and this formula. Your slope over here at this particular point, 210 degrees, will be minus cotan of 210, and you can easily solve this out. What would it be? Think about it, trigonometric ratios for a 30-degree triangle, because that's a reference angle for 210. 30, you have here a 1, 2, root 3. In the third quadrant, your sine and cosine are negative. So what will you have? You have this minus sitting out from this formula. Then you will have cotan, which is a cosine of this. You'll have a minus root 3 over 2, because again we're looking at third quadrant, divided by sine, because cotan is cosine over sine. Sine of this 30 is a minus 1 over 2 in the third quadrant. These 2's cancel out, the minuses cancel out, your end result here is a minus root 3, and that will be the slope right over here, minus root 3, and we're done. And you can pick any value here for your angle, theta, and run it through this formula right here. This being your formula, it will work out. Radius will be irrelevant. You can just send the angle through, do the cotan of it, apply a negative, and that will be your slope of your tangent line on that unit circle. That's what I'm showing you here. Have a good day.